welcome to my V-Glacé channel. Today I am going to explain getting start to V-Glacé English version. Firstly, I would like to show you rough overview. The first thing to start is this window. It's called the V-Glacé controller. You can choose glass material from the list of this panel. I will choose the first one as a glass material. There are options like this, but we plan to add more materials in the future. When you choose one of these, comment will appear like this. I also choose the material for the mold in this list. Please look at this portion. Two buttons are placed here. First one is to start mesh creation software and another is to start result display software. In English version, free software called ParaView is used as post-processor. ParaView is free software. It is the software which is used in various places around the world. It has many functionalities and is basically in English. Also, it works not only on Windows but on Mac. We provide ParaView data. So, you can work around various data from V-Glacé results on ParaView software. The V-Glacé mesh software screen comes up. Now I'm pressing this button. These numbers are the amount of memory secured. There are a number of 1, 2, 3, but I think the first one is fine. Sometimes it is necessary like number 2 and number 3. For example, you are dealing with large size model. I think you'll be fine in this first place usually. When V-Glacé mesh software has been started, to generate complete model, press the Make All button. As a feature of the software, first, there are some template models in this parameter window. You can change any parameter and attributes of the shape from this parameter window. It will be in the form of calculating. This model is the spherical shape, which means ball shape. I will set the vertical ratio value as 0.5. Press the Make All button. Then the shape of vertical ratio changes 50%. This is the form. I will use it like this. Currently, in the English version, there are two models as a template model. First one is the spherical model, and another is the meniscus model. We have a model here. Based on this template model, you can change any parameter and obtain suitable model under certain model conditions. And then you can calculate the model. In this view, drag the mouse with press any button. Then it rotates like this, and parallel translation is to click here to move. Scaling is this button, plus or minus. This button is the fit, which means auto scale. When aligning the direction, press the upper left button like this. To change direction. Well then, this model, I would like to change parameters and calculate. Before that, I would like to briefly introduce it here. Both displacement control and load control are possible. You can choose a displacement. The loading portion of this die is the top side of the upper die and bottom side of the lower die. It is said that only the same value is applied to both sides. The displacement control calculation is better than load control generally in terms of the stability. On the other hand, the force control is more practical. Displacement control is more stable. So today, I would like to demonstrate with displacement control. The rest is the shape parameters. For example, let's change the shape here. This is the diameter of the glass. The red part is the glass. It will be so the blue part will be the die. I will change some of parameters of this list. The upper die diameter changes to 21, the lower as well as 21. This is the radius of curvature. Let's make this a little bigger. If you make all as 35, it will look like this. This is the shape, then this mesh. But this part is a little rough. Set the mesh to 5. The mesh changes like this. And this middle direction is now a little. Try dividing it into 6 parts to speed up the calculation. This will reduce the number of elements, so the calculation is faster. In the bottom, the number of nodes and the number of elements is out now. 2,166 elements and 1,429 nodes. This is the temperature sequence. From this graph, you can see the current temperature. 580 to 100 at 580. Keep high temperature and then slow cooling. The displacement currently is 3 millimeters up by 100 seconds. The upper die is going down 1.5 millimeters. The lower die is going up 1.5 millimeters. It is set the glass to be crushed. For example, although it is 580 after keeping at 580 here is. It's 500, you said you changed this temperature. For example, 500 if you want to change to 450, use this. By the way, I will enter. Put 450 equal to this to the graph I would like to draw your attention to. In this way it will be reflected. Let's put it back for now. Then let's go to the next step. I would like to run the calculation. At the output you can save it anywhere. So, for now, name it test. Not to mention then below a calculation execution panel will appear. In this state home, in this state executes when the button is pressed. Like this a DOS window pops up. Another DOS window is there. This mesh creation software, it was open when I started mesh creation software, and this is working all the time. It's working behind the scenes. When the calculation result comes out, convert the result that can be read into ParaView. If you look at the bottom left, it is currently number 1. The first result is ended and first one has been written. If I wait like this for a while in order the calculation result is written and now the second is. It was written, but it looks like this. Write in order and finally 99. Results are written out. In the calculation DOS window, Armin is 1 time division. When the calculation is progressing smoothly, 1.0 times 10 to the minus 3 in several degrees. It's going to change, you should monitor this value. If it becomes extremely small, calculation code is very difficult. You may have a problem with a model that gets stuck. Sometimes it's simple and easy. In some cases, it is difficult to calculate. The far right is the total time. Is set in the model earlier, for example here. By 100 seconds keep the temperature up to 100 seconds and in the meantime. Pressing the die and then crushing it so. If you can reach 100 here. When it comes to the end of crushing, it starts from there. In the form of cooling for up to 260 seconds. I've gone up to 4 now. So here I would like to see a little progress along the way. But please open this, where I saved it earlier, this test. Well, the test and there is a folder called. It's called a test_PV. Folder 2 is being created. The result is saved in a form that can be read by the view. It is stress and temperature and there will be 2 folders called. First, with this software called GraphR I would like to see the reaction force here. Please open. Horizontal axis is time, vertical axis is reaction force. Like this, time and reaction force relationship is displayed as a graph. If you reload this appropriately every time I get a result, I think they will be added. Has increased now. You can see the reaction force like this. Then have a look at the folder of the results we just saved. Input file. This will be the result holder. A place called reaction force. Well, apart from this graph you read earlier, there is another one, of reaction force this is. Well, simply like this in CSV format to why is it listed. This way if you could write a graph in Excel the reaction force. It means that it can be graphed. After that there is a notes I got the coordinates. It's a node on the glass surface. X coordinate, Y coordinate and square it, add and root. There is something I got, but with this R between 2 of Z if you write the club, it will be a glass like this. Of the surface of this means that the coordinates can be obtained. So, this and number 8 this time, it's the stand. Number 8 on the die upper side. Of the graph let me draw a graph for you too. If you give in this way, the surface of the die, since we can take the coordinates, these. If you can see the positional relationship between them, I am getting this result in the sense that. Well then let's start the result view software called ParaView. You can get via free download. I will open the results. Open result folder in ParaView and this it's open and apply. It will be displayed like this and how to display. With edge like this and the result some results have been obtained. Looking at the maximum principal stress from maximum principal selection. I will see. This is number 1. This color it's not good, so please reselect here. Rainbow's blue to red is this. Animated by when you call I feel like this. If you set this range to auto here I think it will be a color that is easy to see. It is also possible to take out only the glass. Moreover, since this is already a function of paraview, although it would be better for you to investigate only glass part, I will briefly introduce. Select some of the elements first, then keep pressing this plus. If you have selected up to the boundary so far, this. Press the eject button, then press apply. You can only see it here. Over here surface with edge 2 and this if you run here you can only see through the glass. It's like that. It's up to 13 now. Since the temperature has not yet done in the cooling process, I think that the temperature remains constant, so I will check it after the calculation is completed. To cancel the highlighted selection, press the trashcan button here. It will take a little time to calculate, so leave it as it is. After the calculation is finished, I will check the result. Let's see the progress. Then, I would like to end here. Thank you for watching.